Hi, a very good evening to you all. Let me welcome all of you to the third series of webinar organized by Healthcare Engineers Forum, CAHO, on hospital electrical safety devices and technology. Electrical safety in the healthcare sector, as you know, is a topic that needs to be talked about more often. With the current IT and IoT-enabled technologies more in use, uninterrupted power supply is essential for a seamless hospital operation. Safety in transportation and safe use of electricity ensures less risk of explosion and especially fire. However, as you know, electrical hazards do happen. As per National Crime Records Bureau, the frequency of a death due to electrical hazards, the so-called electrocution, in India per year averages to around 12,000 to 13,000. That means it is alarmingly around 30 plus per day. So that shows the criticality of this particular topic. A patient in operating room may not be able to react or reciprocate in such a hazardous situation. In addition, the natural impedance of human skin, there is a natural impedance in human skin as such, which is getting compromised in certain circumstances, such as when you do some procedures like insertion of a catheter. A current of even a small quantity, a 30 milliampere, for a fraction of a second is sufficient to cause cardiac arrest. Another one criticality due to which can be linked to this fire electrical safety is fire incidents. The fire hazard due to electrical short circuit or overloading or is another critical hazard. Around 17 severe cases, fire hazard incidents were reported in India during the COVID period. During COVID, there was a rise in the use of ventilators in ICUs, which created an oxygen-enriched atmosphere. That may be one of the reasons why this got escalated during the COVID period. This enhances the risk of fire since oxygen support combustion. So, in order to ensure user safety, regulations had been there. Definitely, from government side, regulations had been there, introduced over a century ago. To be precise, on 1910, we have our first safety regulation based on Indian Electricity Act. There are other regulations as well, such as National Electric Code and Central Electric Authority regulations, which are also there to control electrical hazards. Nevertheless, the frequency of electrical hazard is not going to come down. It is steadily increasing. And this shows the importance of further study and modernization in this field. Today we have with us Mr. Amit Mishra from Schneider Electric India Private Limited to take us through some of the modern technologies and automation ideas which can energy efficiency is also one of the major things which needs to be thought of in parallel to the safety. So automation ideas will also be there which can help us to in electrical earlier detection and prevention of similar hazards. Let us join together to welcome Amit Mishra. Mr. Amit, and I would like to give a small brief about Amit. He's heading the healthcare segment for Greater India operations for Schneider Electric, and in his current role, he's into so many things: end-to-end business growth, key accounts management, IoT-enabled service especially for the healthcare, then marketing and business promotion. Amit has got some 17 plus years of rich experience, and he's very much expertise in sales, marketing, pricing, and business development. Let us welcome Mr. Amit. Amit, over to you for your presentation.
Thank you, Mr. Biju, for giving us a complete introduction about the importance of electricity. And again, I must applaud for CAHO, because second time that as a Schneider Electric, we are participating and sharing our thought on electrical safety. So basically, we'll start by our session. You all are aware that the importance of healthcare industry. So healthcare industry is the second most electro-intensive building across the globe. And the second most important and amazing fact about healthcare industry, that's one of the second most complex building after nuclear power plant. So that you can understand the importance and nitty-gritty of the healthcare industry, because life is at the stake. And in healthcare, there is no time for downtime. So by a small glimpse of Schneider Electric, most likely that you are aware about Schneider Electric history, that Schneider have lots of company across the globe, and we are there from electrical and mechanical side, and we are the global leader in the digital transformation of energy management and automation business in India. We have more than 32,000 employees. We have 32 factories. So we are dedicated towards India. We have all the factories make in India concept base, and more than 50 plus we have point of sale. So we have a good footprint across the India. And the beauty of whenever we start about healthcare and the sustainability, because in last session in CAHO, we talk about sustainability, how sustainability is impacting on healthcare. And this topic, we are going to talk about the electrical safety. So electrical safety started with the designing of the hospital, which is the first phase. And the designing during the COVID or unprecedented time that we all have witnessed, how we are managing those patients from 200 bedded hospital to 500 bedded hospital. So this is the time the new technology which has come up called ETAP, how you are formulating or designing simulations so that you can your complete hospital, it has to be flexible. Second phase, whenever you are hospital being a complex facility, that's a very strict timeline for that you need to complete the project within 3 years or with a limited like budget. So in all those financial concerns, with the beauty of this 4D 5D simulation, the latest technology which is available, that you can easily find out the progress of the project and the estimation very clearly, and the operate and maintenance where electrical safety comes. So it will cover those points, like how a smart hospital works. So a smart hospital works with the very inception stage of the designing, where all the connected product comes, like electrical substation, where we talk about the complete transformer, HT panels, or the LT panels, and the lots of electrical devices, because electrical it impacts all across the hospital, and basically it's an asset, it's a human life, and there are lots of financial losses as well. So how will make it more smarter from the substation side to final distribution, like in your OT room, ICU room, CT scan, MRI machine, so that if anything goes wrong in your premises, you will get to know early how things will affect. Because Mr. Biju has also highlighted this fact that if you go to the statics part of the complete electrical industry, that after natural disaster, electrical is the single cause, the fire is the single cause which is affecting a lot in healthcare industry. And most of the fires are related with the either loose connection, degraded connection, or the termination issues. So those are the very frequent causes. And in every 7 days that we have a dedicated front line that will got to know that we are getting this news that there is a fire hazard. So how will protect our system? And 25% of electrical fire are due to loose or faulty connections. So within these things, in upcoming slides, that we will understand what would be the latest solutions that we can protect or we can mitigate the risk of fire. So first and foremost thing is important from this designing of infrastructure, either with your transformer part, the substation, or goes to the LV distribution network, and finally go to the final distribution network, your OT, ICU room, or the different building connections. That you need, whenever we are going to select any of the products, it needs to be qualifying the premature criteria, the initial criteria of the like the harsh environment, corrosion, aging, how they are encountering it, or the losing visibility, connections, potential hotspot, how you are going to encounter. So some of the latest product and solutions which is available, like thermal sensor, humidity sensor, so that you can mount on your transformer, HT panel devices, RMU, even SMA sets. Basically, it's a SF6 free circuit breakers for vacuum circuit breaker. That hope you heard this terminology, VCB and RMU. Now it's also been replaced by the SF6 free circuit breakers. So what we are trying to do that if anything goes wrong at the certain level or certain if crosses the temperature 90 degrees centigrade, so automatically the maintenance staff will get to know what action he needs to take in case of the complete switchyard from transformer level or from the LV distribution network like your LT panel, wherever the major challenges of the fire occurs in any of the hospitals. So in those hospitals, you can easily mount those Wi-Fi based sensor. It works on the Zigbee technology. And there is a one gateway called Zigbee gateway will automatically communicate and it will give this information to your edge layer software, and automatically the BMS person or your EMS person will get to know that there is a problem in your transformer or your HT network. And the most interesting part comes because whatever we are talking about, it's basically a preventive maintenance or reactive maintenance. How will make our system more predictive, that you can take your action as in advance. So we have a beautiful solution called insulation. It's basically a heat tag device which works on insulation decomposition detection. Means it automatically analyzes the gas particle and microparticles in the air. And whenever we are talking about air, it gives the different 11 levels of air quality, as well as in its inbuilt quality of 3 levels of severity that you can define, so that you can call it as electrical nose of the electrical system. So whenever any joint, any leakage it comes, and the fire is going to start by the graph, automatically it's sensed by the gas or the microparticles, and it gives the alert notification to your any of the SCADA software or edge layer software, that it will protect, it will give the alert notification to your system that you need to switch off, or you need to like disconnect your the devices, so that your system will be protected. So this is the beauty of heat tag devices. And last but not the least, like arc fault protection devices. So whenever we are designing any infrastructure, we need to remember the first thing and foremost that from substation level, there is a transformer, so for the distribution of the power, and after that there is a device. If any arc which is going to be occur in your system, so with the help of those arc fault relays, that it will sense the lux level as well as the CT level, and it gives the notification to your incoming breakers, and finally your incoming circuit breaker will trip. So basis on your lux level as well as rate of rise of current over preset value, basically it initiate the trip. And the second most devices like eSurgy relay, it's also a communicable device. If anything, the same parameter it will work, but the differentiation between arc fault relay and the eSurgy relay is that if you have a complex system and if you are designing a big hospitals, so in every device, if you want the dedicated protection, so you need to mount this eSurgy relay, so that if any arc which is going to be arise and it will affect the system, automatically it trips the circuit breaker within a second. Within 40 milliseconds, that automatically the complete system will switch off, and it will protect the system. And nevertheless, from the MV side, that we have a same similar kind of solution from the LV network, wherever the LT panel comes. In LT panel, there are lots of technology has also arrived, like IC 61439 panel, which is very common nowadays. All the hospital is talking about TTA panel and most advanced Prisma panel. So the same way, that arc fault protection relay that you can also use from your LV network. And whenever we talk about your ACBs, air circuit breakers, or your MCCBs, which is near to the load, in that time that recently the technology has evolved called ERMS. So ERMS is basically energy reduction management setting. So what they are doing it, if there are lots of circuit breaker are interconnected and we are supplying to the complete building. So if you have done the wiring of ERMS basis on your mobile or any of the edge layer software, it will, if it is connected, so there is no intentional delay. It will automatically trip within a second. So it will protect the life of the person as well as the complete installation. So ERMS is a mandate for European country, but now EMA and IC are talking about to mention this fact. Even the new tender and the new specification is coming up with ERMS as well. And the last part of it, if you're talking about the room, so how to protect the human being, like the patient room, OT, ICU, so how you can protect for those small kids from leakage or the fire. So there is a beautiful device called arc fault detection devices. Earlier, we have seen this arc fault protection relay for 11 kV or 33 kV or 66 kV, the higher load. Now we are talking about your own room or your own hospital, how to protect from fire, which is a mandate for all the US and European country that they use, like in India, we use RCCB, or the similar fashion, they use AFDD as well. So with the beauty of AFDD, it's also work in the same technology like arc fault protection. If any arc arises, automatically it gives the command to MCB, and finally your complete system will be isolated. And with the beauty of edge layer software, if you have any SCADA BMS software, so you can fetch out all those information to your edge layer software, and your maintenance staff will automatically manage from the remote. And last but not the least, in any of the hospital, there are lots of CT scan, MRI machines, and the devices. So how you can protect your system from harmonics? And in some of the hospital, if you talk to your facility manager or operation and maintenance guys, they will admit the fact that sometimes they have a issues that your MCCB is tripping, or your ACB or any fault protection devices are tripping, but they are not getting any of the reason, because it's not captured in any of the circuit breakers. So what you need to do, because in such cases that you require advanced metering. So in advanced metering, that you get to know that what's the different SAGs, well, disturbance direction detection, individual harmonics up to the 63rd level. Basically, if I'll give you some of the fact of the hospital, if you have the issue of like humming sound coming from your transformer, or burning of the capacitor panel or the contactor, or some of the facts like overheating of your cable. In such cases, there is a single predominant issue is harmonics. So in such case, that very beautiful meters has already been come up into the market, like their accuracy class is 0.1 S, and the sampling ratio is 1025 sample per cycle, so that you can register those information, and finally you protect your capital equipment. And from the LV switchboard part, which we talk about LT panels, there is a dedicated solution inside the metering that you can protect from 0.2 S level. And finally, the LV distribution, if you want to monitor the consumption of your OT or ICU rooms, let's say how many surgery has been done and the basis on the power consumption. So there is a beautiful device which will be mount on your MCBs. There is no cabling is required, no connection is required. It will directly mount on your MCBs, and finally it will give you the command. It will give you the complete current, voltage, energy parameter. Even if you have a big hospitals like 600 bedded hospital, it will be very difficult for your maintenance guys to protect the patient as well as the maintenance staff if anything goes wrong, and some leakage current is coming up during the rainy season. So with the help of those Wi-Fi based sensors, you get to know that room number 203 have issues, or some child is playing with this electrical switches. So and that time that you can protect. So those all are intelligent devices. It is started with heat tag, power tag, thermal sensor, arc fault protection devices, arc fault protection relays, and finally goes to the metering part, like power quality plays a major role. Even it also initiate the electrical fire. So now we are moving towards OT panel. In OT panel, we got to know that in all the hospitals that's they required, and basically in all the OTs, their top priorities: power reliability, system redundancy, earth leakage, and electrical shock. And all the OTs, basically they are supplying either diathermy machine, ECG, heart lung machines, suction machines, and protecting the human being. So as well as the IC guideline for across the globe, there is a mandate. IC 60364-7710 that you it's near to the patient that you need to change your earthing system for TNS to IT earthing system, and we are basically talking about isolation transformer. So how to protect the human being. In such case, there is a dedicated device called insulation fault monitoring system on individually that you can mount on the different loads, or loads 1, 2, like diathermy machine, suction machine. If anything goes wrong, like nurses is basically providing the supply in any of the socket, and socket have the issues of leakage, because in that sense, how doctor will get to know there is some issue, so that patient will secure at that time. Because Mr. Biju has also highlighted that 30 millisecond, 30 milli ampere is dangerous for normal human being, but for the patient, is 5 milliampere is also very much dangerous. If it's basically a dangerous situation. So at that time, the insulation monitoring device will give this alert notification that fault socket number 2 is faulty, so don't use it. The same time that it will reflect the uh, your socket number as well as the kilo ohm, the fault level as well, and reduce electrical shock, downtime, everything. And in traditional, that I have clicked those photographs across India, in most of the OT and ICUs are getting the power normally from the only MCBs, or some of the cases is RCCBs. So RCCBs and MCBs are not meant for OT and ICU's application. OT and ICU application is most precise application wherever you require the dedicated leakage protection or the leakage monitoring. So in those cases that you require isolation monitoring devices, and each level that you will get to know that what current is flowing and how it's affecting. So there are dedicated two offers that you can also integrate with your BMS. You can do this temperature, air monitoring, and got to know even you can do this monitoring of your light, even the different control level, and finally get the complete function ready-made. So these are single phase and 3-phase supplies, and the fault location as well depends on your OT, number of OT that you can design your OT and ICU's panel. That is a IC guideline. And then we'll move to the third topic. So third topic is basically a command and control center. Why we are talking about a command and control center? Because during the COVID that we all have witnessed, that in such a critical conditions, you can't operate, you can't maintain your hospital from inside your facility. So how you can manage your facility remotely? And if you have a number of hospitals, so by a single click, if anything goes wrong in any of your hospital number 2, hospital number 3, what kind of alerts, what kind of fault are coming up, what action you need to take. So with the beauty of command and control center, that you can manage those facility, and how we are managing those systems. This is a SCADA software based on the command and control center. We are tracking all across, even ambulance tracking, COVID-19 room information, like how many patients are there, even the vaccination information, CCTV coverage of the facial impression of the patient, GIS, ERP integration, firefighting, HVAC information, because automatically it travels into the complete environment. So how you can protect your environment basis on the complete integration of your pressure, humidity, and the temperature. And last but not the least, like oxygen gas plant. So in that case, that with the help of those complete SCADA system and command and control system, that Delhi government is also managing more than 200 hospitals and fetching out all those information, slicing and dicing of the data, and finally they are doing this data playback, analytics, what kind of information or the oxygen consumption that you required. So those things are in place now, that all notification informations, cloud, with the help of machine learning or the analytics part, that we are providing those information if anything goes wrong in all these information. Because traditionally what we are doing it in all the healthcare infrastructure, that we are integrating the mechanical and electrical system. Even some of the cases we are integrating the IT part of it. So it started with the electrical substation, only fetching out these electrical consumption like kWh, kVR rating, or the ampere, voltage, and everything, the harmonics critical part. And mechanical side, the integrating with the public address system, fire alarm system, and CCTV, and AHUs, HVAC, OT, ICUs with integration of UPS. But now the more and more complexities are involved, so that you can help with the help of those SCADA system, that you can get all those information by a single click. And this is a project which we have executed in Sikkim, Namchi city. Is basically a hospital project, a smart city hospital project. In all those information, it's a city surveillance project which started with the transportation, finally goes to the your water sewage system, and goes to the your healthcare system. So in all the private hospital and the clinic level, what surveillance system they are tracking, vehicle tracking system, railway and transport system, with regards to the patient information of COVID and everything that's are registered at the central level, at the central repository level. And finally we are provide with the help of AI and machine learning, we are providing those information to the city surveillance or the central level officer, that what action you need to take if anything goes wrong like COVID. So at the central level, what action you need to take to mitigate. Even all those informations are registered and providing those things. So this is one of the glimpses which we have executed during oxygen plant automation across India, and more than 10,000 plants are running on those solutions. That it's centralized system, that and even in Delhi and few of the states, that we have done the automation and providing those information to the government, like how they are fetching those if inventory stock of oxygen, in how many hospitals they required, or number of consumptions, number of consumption of oxygens, so that government will take predictive actions basis on those consumptions of these oxygen set or oxygen plant basis of the hospital information. So we have a dedicated SCADA software that my colleague Rajesh will showcase within 10 minutes, how this complete smart hospital works, how this SCADA software will talk on different HIS, nurse call system, or your HL7 protocol, or third system, third party proprietary system, so that your complete system will work on one uniform digital network. So over to you, Rajesh.
Thank you, Amit. So thank you very much, CAHO team, for giving Schneider this opportunity. And I think Amit has very nicely explained on the PPT about all those solutions, what Schneider, what electrical safety, all about it. Now, like what Amit said is, we just thought that why not to show you the actual glimpse of the software, which how it enhances or how an intelligent infrastructure can lead to improving the patient care, patient safety, and patient satisfaction. So since our topic today is related more on the safety point of view or patient safety, we will focus on the safety aspect first. Now we talked about the electrical safety. Okay, so safety is not only on the electrical part in an healthcare segment, but there are a lot of other safeties very essential in an healthcare, like safety for the data, that is the cyber security. A lot of patients' data, their reports, their treatment, diagnosis, all are stored in the hospital information systems, and the security of that is very, very important nowadays. We heard couple of years back, or maybe 3 years back, there was a cyber attack in a private hospital in Mumbai. An unidentified hacker has locked the data in the hospital computer system, and he has sent a web link demanding the ransom in the bitcoins to unlock it. So, in addition to the electrical safety, safety of the data is also very important. Third, very important factor about the safety is the uh, hospital acquired infections, or in a uh, clinical terminology they call it as nosocomial infection. What does it mean is it is the infections which is generally not there when the patients are admitted to the hospitals, but they acquired it nosocomially. That means because of the spread of germs they may get some another disease and other things. So that's again very important aspect from the safety point of view. Then safety, nowadays we have seen in the pandemic situation that safety from the lack of medical gases, that is also very very important, that we need to get an alert if the oxygen level or if the other gases pressure or the supply is less. Okay, it should be immediately informed so that the respective people can take then immediate actions. And then very important is the safety of infant abduction. Now in India we have found that a lot of places, the infants are getting abducted from the hospitals. So the safety of those infants are also very, very important. Now, having said that, let me just quickly move to the actual demonstration part of the software and how these features can be seen in that demonstration. So one is very important, like we said. So this is the software. What you can see on the screen is the BMS software of Schneider Electric. We call it as EcoStruxure Building Operations. And just to mention here that we don't use the traditional HTTP connections when we connect to the database. We always use the 128-bit encrypted secured communication. Okay, so you can see here we don't use the non-secure, it is always the secured communication. Then you have the credentials using which you can log on to the system. Now, as you log on to the system, you can see here a second level of cybersecurity, the IP whitelisting. It will check whether the IP address it is trying to log on, does it have a trust secured certificate or not. Then once you log on, then you have a lot of other features by which you can actually protect the data. You can see it here that we have got a password policy. So the customer can have their own password policy for the software, how often the password should get changed. All these, what we are trying to show is that it ensures that your system is all secure. It is not that anybody can just hack those systems and the important data is at stake. So with that, we will go quickly to the hospital demo. So if you can see here, this demonstration shows about the entire campus. Maybe it has got multiple buildings, multiple floors. And from here, we can see that when a patient gets admitted to the hospitals, generally they will go to the ground floor where normally the admissions are happening. If you want to go to the various other floors, like on the second floor where OT, you can just click on the mouse and you can go to the respective floors. So once the patient goes to the hospitals, now generally hospitals are energy intensive buildings. They are operating 24/7, so energy is continuously being consumed, and the HVAC systems, the ventilation system, does not really know the flow of the patient or how often the spaces are being utilized. But the hospital information system has got these informations about it, and the integration with the HIS systems, with the BMS systems, can fetch you that data into the BMS, which will tell you like how many beds are there and what is the utilization of it, how many are available, ICUs, how many are beds available. Now we know that recently in pandemic situation, these informations were very, very vital. How many beds are available and this. So the integrated systems, the BMS along with the HIS can get that information to the facility team, which can very effectively manage the patient's inflow. Now, once we go inside to the software, we can see here that it will also tell you how many rooms are occupied, how many are under cleaning, how many are under housekeeping, all that informations can be readily available. When the patient gets admitted, generally they are put with the tags, the RFID tags onto their hand, so that the patient journey can be tracked. When the patient is moving to the various departments, integration with that RTLS, real time location systems, can be tracked, and efficiency of those particular room, how much time he has spent to the admission counter, how much time he has spent to the blood bank or the blood testing lab or the CT scan or the MRI. So those efficiency can be tracked using the integrations with the RTLS system. If we can go further onto that, it will also tell you about how many beds are being occupied, which are under cleaning, what are the temperatures are being monitored and maintained in the various rooms, where are the hot spots, where are the cold spots, and these can all be utilized from there. So once the patient goes to this, and then the admission, the receptionist in the admission, she will make that, okay, she will allocate this room to the patient. By the time the patient goes to their room, okay, you can see here, okay, so what I will do is just, so if you see initially the patient room will be like this. When they are not allocated any room, generally the lights will be off, the AC will be off. These will ensure, the BMS will ensure that the energy is not getting wasted when the patients are not there. And the moment the room is allocated, that particular room, to the patient, you will see that now the lights are turning off, the air conditioning is on, the room status is getting changed. Now, we have also talked about the nosocomial infections or the hospital-acquired infection. Now, this is where the temperature control, the relative humidity control, and the pressure being monitored properly is being done by the BMS systems. The connected room solutions ensures that all these parameters are nicely properly maintained, and the positive pressures and the negative pressures in the respective areas are being properly maintained, and there is no spread of viruses from one area to the other areas. Now, if you also see here, the patients are provided with the control panel like this, or the bedside panel. The new technology calls for even the apps wherein the patient or their relative can scan the QR code, and on their mobile they can get something like this. So the patient need not have to cause the nurses for changing the temperature, opening the blinds, or switching off the lights. They themselves can do it from the app. So if they want to switch off the light, the patient can do it themselves from these equipments. You can see here the lights are turned on, or if they want to open the blinds, they can just or close the blinds. If they want to change the dress or something, they can just close the blind, do that and do it. So here the efficiency of the nurses can be effectively utilized for the productive work. Nurses are not meant for changing the temperature or the set point or the switching on and off the lights. This is how it will help. Second is integration with the nurse call system. So if that is integrated with the BMS, if the patient want a nurse, he may press here on the nurse on this, and if you go to this particular room, you can see here on the user interface they will say that room number 201 the nurse is calling. However, you can also see here a timer is started, which will effectively indicate how fast the nurses are responding to that. So the moment the nurse goes to this room, she will have to press this button, and the counter will stop here saying that okay, she has responded within 22 seconds. So the integrated approach with the various systems with the BMS will be effective for doing these kind of things. The moment, suppose if the patient has to go out for some testing, or maybe some blood test or the CT scan, okay, he may go out, and you can see here the occupancy sensor will sense and say that okay, he has not checked out, but he has gone out, it is not inside the room, it is in unoccupied mode. Automatically the lights will go off, the blinds will close, which will ensure that the efficiency of the energy is done. And air conditioning, because they cannot close the AC, or they cannot switch off the AC because the patient is still not checked out, it will be running but at an higher set point, ensuring that the energy is optimized. Now we go on to the another very important room, which is your operation theater or the operation room, where this is very important because uh, downtime of power or HVAC or any medical device is not acceptable in this area. So all the electrical systems has got proper backup to this systems. Again, you can see here, you can find out how many OT rooms are available. And if they click onto this, okay, if they allocate room number 201, it will go into an preparation mode. And we can see it here that uh, the doctors or the admin people can actually do the preparation of that OT room. They can test various systems, whether the insulation monitor is all correct or whether there are any other faults. It would be tested. If they want to put the timers or depending upon what kind of operation they are performing, they can set the temperature, okay, the humidity, and if they want to switch on, only the surgical lights, or if they want to, switch on the entire room lights, they can do it from this. So once they prepared for it, they can set what are the positive pressures they are looking for, or the air changes, the gases conditions. All once they are done, they can just lock it and goes into the operation mode. Now, if we see here, now we're talking about the electrical safety. During the operations, you can see here that the OT panel will show you this display about the temperature, the lighting, the pressures, the air changes, and the electrical things also, whether the power source is normal, UPS is healthy, all insulation, everything is all good. Now, during the operation, if suppose there is a mains failure, okay, now in that case, what will happen is that you can see here the power source is now gone to an UPS. Okay, so when the power source is gone to an UPS, you can see here it will reflect here that the power is gone to an UPS. Maybe the UPS has got a 20 minutes backup, and if the operation has to prolong for a longer time, the doctor may decide whether they can continue the operation or they can switch over to an DG. Okay, and once it goes onto an DG, you can see it here that it would change the power source from here to an generator. And you can see it here that there is an electrical fault, but now it is running on a DG, and the people can, or the doctors can continue with their operations. And then, so what point we are trying to say is that the integrated approach of the electrical system really helps about the patient safety in this case. The last but not the least is very important aspect is about the patient infant safety. So the infants are tagged with those RFIDs, and if any chance, if any floor, if the baby tag generates an alarm, it would immediately pop up a CCTV image of that particular room and will tell you that this particular room, the door is opened, it's critical. And if it is integrated with an access control, that particular floor or that particular area, we can go into a lockdown mode so that all the doors will get automatically locked. And from the camera, we can trace out where the people might have taken that infant. So this is just a small brief about the building management system demonstrations. More precisely, we have talked about the safety features, how the electrical safety, whether it is insulation monitoring, whether it is the safety from the hospital acquired information, infections, or the cyber security. We have touched upon all those points and even the medical gases. I thought it was useful. Over to you, Amit.
That's all from Schneider's side. Now it's over to you.
Thank you. Thank you very much, both Mr. Rajesh and Mr. Amit. The presentation was quite useful, informative, and interesting. Now we can move to the question and answer session. I'm just waiting for the questions to be typed in the box. Till then, let us clarify a couple of small concerns in that. You were talking about whenever there is that arc flash indicator monitor or isolation monitor, you have been talking about a lot of other devices. Do you need a HLA software or a SCADA or a BMS for to be integrated with these particular devices?
No, it's not required. It's not required.
It's not required.
No. It's basically a connected devices. It will protect your system. If you want to take those information to your edge layer software, any of your SCADA and BMS, you can do that. But from the protection point of view, it's not required.
Okay. So it's just a plug and play. That's what I could understand, right?
Absolutely.
Okay. And my next question is to Mr. Rajesh. You're talking about this. It's a BMS or a SCADA based system. What you have been talking about? This one.
It's a
It's
building
a
management system, BMS
it's a
system, correct.
BMS system. So how feasible it is to go for a retrofitting in a hospital, which is already built some 15 years back?
Very good questions. Okay. Yes, we do have a solutions for retrofitting the BMS in an aged hospitals where they do not have such a sophisticated system. Uh, they can go into the stage wise. Okay, first about the equipments need to be communicating. If you really want to connect to an BMS, like the energy meters or the UPS or the chillers, if you need to integrate that with the BMS, you need to have the smart meters or you need to have the open protocol supported systems onto that. So you need to first get those third party equipments communicable. Then at any point of time, we can deploy the controllers and the softwares. Yes, installing those devices or installation of the cabling in a running hospital is often a challenge, but we do have some solutions by which we can reduce the installation part by deploying some of the wireless sensors so that we don't need to lay the cables and this. But to answer your questions, yes, it can be the retrofitting can be done in the old hospitals also, and we can upgrade. We have done in the past also few hospitals.
Oh, thank you. And it's a monitoring system or a controlling system. It's a monitoring system, I hope, rather.
So if you see, it is when we talk about the HVAC system where we have to control the temperature or pressure or to relate to humidity, we do the control part. But majorly the control part is on the HVAC system, the air conditioning system, and the plumbing system where the pumps are there. So that if the water level in the tanks are going low, we start automatically the pumps and to ensure that the tanks are always filled with it. On the third party systems like the lifts, the DG, the UPS, it's majorly on the monitoring part of it.
Okay. And I hope we need some guy who is expertise in this field to monitor and analyze the data which is getting, collected, right?
Correct. So you are absolutely right. People always feel that if you install the best of the BMS system, you would get all these parameters automatically. Not to 100% because as the load changes, as the site condition changes, you may have to deploy different strategies also to see that how the energy can be optimized or how it can be best suited. And hence, the operation or the facility team need to really analyze this data periodically and see that where all they can save the energy. To answer that question, Schneider has come out with a third party or the third layer, which we call it as an IoT layer or the advisory layer, using which it will do the consultancy role for the customers, where the customers do not have the people who are competent enough to analyze the data, or sometimes they have the competent people, but they do not have a time to do this analysis. There, Schneider can support by the advisory level, whether it is an HVAC advisory or whether you want on the electrical power, we have both the advisories available.
Oh, thank you. And someone has raised a question, and the question I think it is to Amit. He's worried about the quality of wires and other devices. How to select, or do you prefer some code or any specification which you can recommend for going for these wires and devices?
Yes, Mr. Biju. So we have a dedicated hospital architecture, and the complete specification is also there based on the smart devices like heat tag, power tag, which we highlighted. What's their advantage and how it will communicate. So from hospital point of view, that we have created dedicated uh, two dictionary for 300 bedded hospital and 800 bedded hospital, the complete architecture and the information from mechanical, electrical, and the latest solution, how to make digital hospital, everything is there from the specification part of it and the technical specification. So we'll share with you, Mr. Biju, and then you can provide those information to the relevant stakeholder.
Thank you. And see, from the discussion, what I could feel that, so from the concept design stage itself, we should have a proper open discussion with your team or any of such kind of, innovative companies. And we should have a comprehensive approach for design as well, rather than, after completing the construction or doing construction or during construction, going for such a kind of, innovation, adopting in such kind of innovative technology. It is always better to think while you go for the concept design stage itself, right, Mr. Amit? Do you want to say anything about that?
Absolutely, Mr. Biju, because even as per Schneider, what we are trying to promote in the market, in any of the healthcare like a complex system, we need to work more precisely in the design phase, in the inception phase, because at the development, which is very easy for maintaining the capex part, but from the designing or the selection of the product or the technology which we are going to use, like the BIM is the latest technology, and which have a several advantage if you want to do for AutoCAD modeling or the simulation point of view. So this is the right time at the inception age that we need to we need to consider the prices as well and the cost estimation, so that at the operate and maintain phase, whenever we are operating the hospital or the OPEX, how to maintain the operational efficiency, how to make it more sustainable hospital, how to make the use of those the HVAC, AHU, those integration and the alarm and notification as an advance. So it's my advice to all the stakeholders that we need to spend more and more time at the designing and designing phase with the consultant, PMCs, and the cost consultant from the initial time, that what technology we are going to use, how we'll make it more smarter, more digital hospital, so that it has to be ready with future IoT enabled technology.
Oh, that's good. So I think this is the correct answer which we all of us are looking for. And one last question from my side. See, there may be so many administrators, CEOs, and healthcare owners in this particular forum. Just to satisfy their query, what is the capex impact if at all we are going ahead with these kind of things, and how do you feel that once we invest, how we can tap the returns? Other than the safety aspects, I am talking about the safety, and that is the tangible benefit. Always it is there. Intangibly, everyone will be having such a thought in their mind. So do you want to comment on that particular thing?
Rajesh, do you want to address this question?
Yes, Amit. So the cost depends on a lot of other aspects about it, like what kind of integrations are we going to do, or are we, so the hospitals may have many multiple systems, but depending upon the budget.
Mr. Rajesh, sorry to interfere. My question is not about the kind of cost, but there will be definitely, just want to know whether there is an impact of capex other than going ahead with a normal design, and if at all, even if there is an impact, whether it is, whether it can have any returns during operation. That is the question. Simple.
So if I understand your question correctly, what you're trying to say is that if you have to go for an BMS kind of a system or such a sophisticated system, does the capital cost increases? And if it increases, to what extent the returns are being achieved? Am I right?
Yeah.
Okay. Now that's an analysis we really need to do, but I don't have the figures right now. But what I can say is yes, the capital cost increases if you really need to go for an sophisticated systems like this, so that in an operation theater you need to have a smart OT panel, which an insulation monitoring, and which all those devices need to be done. So obviously the capital cost will increase to some extent. However, the returns will not be always as regards to the money, but you have to also see as regards to the safety. Because if you have a power outage during the operation, and if something, unfortunately happens to the patient, the brand of that hospital is at stake, and it's not the it would actually create a bad image in the market, and you will have a lot of commercial losses. Even about the thermal monitoring, like Amit was mentioning, if we do not have those proper safety systems in place, whatever happens tomorrow because of that small incident, it can cause a lot of damage to the image and other things.
Yeah,
And
yeah.
Mr. Biju, I'll summarize with one simple example based on my practical experiences. Let's say if you're talking about 100 rupees for normal connected product, a smart hospital integration, and if you will go with advanced technology like internal arc protection devices, all our communicable protocols from substation to go to the final distribution and the mechanical like BMS integration, you will save your energy and increase the operational efficiency by 30%, which we have the white paper as well. And the cost implication which nearly comes up to the 15 to 20%, because
Okay.
all are the products are communication capable. If you talk about any of the market leader, ABB, Siemens, Honeywell, JCI. So now communication is not, it's not the thing that they are charging extra. It's a free of cost.
And I also feel that
So
just to add
30%
on,
that you can get.
just to add on to your this thing, I think this is the BMS works on the operation. It is a best method for monitoring everything, and by using the BMS itself, we can go for some energy efficiency in the building as well. So that is one of the ways by which we can be paid off. I hope so. What is your take on that?
Absolutely, absolutely. So basis on the BMS that you can improve your operational efficiency part in a lot in various prospects. That's the beauty of BMS. Even we have nowadays, like with the help of those data, finally with the help of data analytics, that we are giving the exact information to the hospital O&M staff that what you need to do and when you need to do so that you can save such amount of electricity. How you can use your microgrid, how you can use your AHUs, primary pumps, secondary pumps, so many information that you can fetch out from the BMS, and finally you can save out huge amount of electricity and increase your operational efficiency.
Thank you, Amit. Anyway, that was a wonderful session from you both. I hope we have answered almost all the queries from the participants.
Thank you very much for the wonderful session. I'm sure many of them have taken back some good take-home messages. So thank you very much and have a great evening.
Thank you all.
Thank you.